So we're here now with Darren, one of our product managers here at Anchor. He's been working in the cutting tool industry for 30 years, so he has a wealth of knowledge when it comes to grinding these corner radius end mills, and he's going to answer some of our questions here today. So thanks a lot for joining us, Darren.
Yeah, thanks you. Great to be a part of it.
Yeah, great. We'll get straight into it. The first question I have is about the land width across the different sections. I noticed that when I was setting this tool up that the land width on the OD, the corner and the end face were varying slightly.
Yep.
Can you explain why this would be happening and how we could overcome it?
Yeah, look, absolutely. The first point I'd look at would be your wheels, your wheel qualifications, especially if you're using different wheels for different operations.
Yep.
So you might be using the cup wheel for the OD and the corner radius, but then you might be using a separate cup wheel to do the end face. So to make sure that your wheels are qualified correctly and the torrid radius on the wheel is correct, that will go a long way in fixing up the land width transitions and the land width sizes.
Okay, so there you go. Make sure your wheels are always dressed and qualified correctly. Very important. The other thing I noticed when we were setting this up was that our gash plane was digging into the OD slightly. Mm-hmm. It was digging into the hook face, causing a little notch on the OD. Could you explain why this would be happening and how we can correct this?
Yeah, definitely. What I would do first up, I would go back and have a look at on the 3D simulator to make sure that the tool's been programmed correctly. If that's been programmed correctly, then I would come in and in your tool room software, you've got a couple of options where we can actually manipulate or offset the wheel or the tool. And that one's being a gash plane A offset and a corner radius A offset.
Okay.
We can then manipulate the tool or rotate the tool towards or away from the wheel in those gash planes to eliminate that undercut.
Okay, and get a nice blend between the gash and the hook face.
Yes, absolutely.
All right, well, there you go. Speaking of gash planes, I noticed also when we were setting this tool up, initially we were getting some facet marks on the gash plane. We managed to correct this. Can you explain to our viewers how we did this?
Yeah, it was quite simple actually. Running out of the wheel, the back surface of the wheel is what creates the surface finish on the gash plane. So it's really important to make sure that the wheel is running true.
Yep.
And if it's not running true up that back face of the wheel and you'll find that you'll eliminate a lot of that faceting.
Great, all right, good tip. My next question is about roughing out the blanks.
Yep.
When we're grinding a ball nose end mill, we always rough out the ball beforehand because we have a lot of stock removal. Does the same apply for the corner radius end mills?
Yeah, it does actually. Especially if you're doing larger corner radius tools where you have a lot of stock removal. If smaller corner radius is probably not so important, but definitely the larger corner radius, if we can get rid of that extra material first and protect our finishing wheels, it's certainly something I'd do. And in our tool room software, we've got an operation called corner roughing, where we can use a separate wheel to take that extra material prior to using our finishing wheel on the corner radius.
Right, and that way we look after our wheel and get more accurate tools for longer.
Absolutely.
The next thing is actually the corner radius itself. When we were setting this up, we measured the corner radius on our Zola and we found it to be slightly smaller than nominal. So how can we correct this and how could our viewers correct this?
Yeah. So depending on which grinding method you're using, if you're using a 4-axis grinding method, I'd certainly go away first and check your torrid radius on your wheel. Very important that that's correct so that you get the correct profile on the corner radius. If you're using fixed point grinding, then I would go into the tool room and adjust your radius input value.
Okay, great, good tip. Speaking of the different grinding methods, in the software I noticed that we have 3 different grinding methods when grinding the corner radius. We have fixed point, 4-axis and 5-axis. Can you explain the different methods to our viewers and when you would use each one? Yeah,
great question actually. So 4-axis grinding is used generally on smaller tools, diameter 3 and under, and especially we're using smaller corner radiuses because it eliminates the machine movement. So we lock out an axis, so we avoid using the C-axis, and this continues to go around the radius, making sure that we get a great tool.
Okay.
5-axis grinding is probably used on larger tools with larger corner radiuses. We can program the various pivot angles so that when we come around the tool, we can use different orientations or different points on the wheel, and that can change our clearance angles. We can utilise it especially on multi-flute tools where we may need to avoid hitting the next flute.
Okay, so if clearance is tight, maybe use the 5-axis method so you can control that a little better.
So there's no rule, but these are the general rules we go to.
Sure.
And fixed point grinding is probably, we class as the most accurate form of corner radius grinding, where it uses the same point of the wheel as it goes around the radius. However, the only setback to that is if we're in a high volume production environment, we may, using that same point on the wheel, we can get premature wear.
Right.
And therefore we may need to manage that a little bit better and potentially have a second wheel pack.
Okay. So for the same reason that we get a more accurate tool, we're also going to be wearing out that single point more quickly, and we have to make sure we have a redundant pack or dress the wheel regularly.
Yeah. So once again, there's no rule of thumb of which one is to be used on any tool, but that's the way we look at it. And there's certainly each method has its benefits.
Okay, great. Well, that's all the questions we have for Darren today. Thanks a lot for joining us.
No worries, thanks you.
Hope you found those tips useful, and hope they help you grind your next corner radius end mill. Thanks again.
No worries, thank you.
Cheers. That brings us to the end of today's episode, and I want to thank Darren again for joining us. I hope those tips help you when you're grinding your next corner radius end mill. I also want to thank Tiralit and Piranha for sponsoring today's show. As always, if you have any questions or if you want us to cover anything specific in the next episode, make sure you leave it in the comments below. Also, make sure you tune into our Tooltip Tuesdays for more useful information that comes out every week. Until next time, good luck with your grinding, and I'll see you next time.